Hi everyone, welcome back to my channel. I'm Miss Merkin and we are going to be going through how to solve for missing side lengths on similar triangles. So to do this, we're just going to go through an example together and I'm just going to really slowly go step by step to tell you the rationale behind how I'm going to solve this problem. Alright, so let's take a look at this example that we have. So here I am given that triangle ABC is similar to triangle EFD. And I'm given some lengths on this diagram. I'm also given some variables that I'm going to have to solve for. So triangle ABC is similar to triangle EFD. And that statement actually tells us a lot because it tells us which parts correspond. So first off, if I have triangle ABC is similar to triangle EF, it means that segment AB, since those are my first two letters, corresponds with segment EF. And what that also means is if I create a ratio of this side, it's equal to the ratio of all my other corresponding sides. And that fact is what we're going to use to solve this problem. So let's see what my other corresponding sides are. So my next two letters are BC. So segment BC, right here, will correspond with segment FD, right here. And then finally, my first letter and my last letter for both of them, I have AC and ED. So those sides are going to correspond. So it means that I need to now find what's called the scale factor, that when I multiply each of these corresponding parts by that number, I get this enlarged, it looks like enlarged figure. So this is what we're going to do first. We're going to write down the ratio of all the corresponding sides just in general terms, and I'll show you what I mean by that. So AC, if I take AC and I create a ratio or a fraction, so AC over ED, that is going to equal the ratio of my other two sets of corresponding sides. So I have AC over ED is going to equal AB over EF, which is also going to equal CB over DF. Now, the only reason this works is because I was consistent about what was in my numerator and what was in my denominator. If you notice, each segment that I've listed, or actually the length of each segment that was listed in my numerator, they all came from the same triangle. And each length of a segment in my denominator, they all also came from this other triangle here. So when you set up your ratios, it doesn't matter what's in your numerator versus your denominator, you just have to be consistent along all of your ratios. So if I decide that all of these lengths are going to be in my numerator, they're going to be in my numerator of every ratio I set up. So I could take the reciprocal of each of these and the statement would still be true. Okay, but just for consistency, I'm going to keep it like this when I use these ratios to help solve problems. So now, I'm going to solve for x first. Well, I know the length of AC is x, and I know the length of ED is 9. So I'm going to start by doing a ratio of those. So x over 9. I'm going to just set up my ratio real quick. X over 9. Now, I want it to be equal to something that doesn't include a variable. So I need to look for a pair of corresponding sides where I actually know both lengths. So that's going to be 8 and 12. So I'm going to set it equal to the ratio of AB over EF, which would be 8 over 12. Okay, so now what I'm going to do is I have to solve this. So there's a couple of ways you could go about this. You could go through and just cross multiply right away, or you could find a common denominator. There's a couple of different methods that teachers will teach differently. But first, I'm actually going to reduce this fraction on my right-hand side just to make the math a little bit easier. So x over 9 is now equal to, well, both 8 and 12 are divisible by 4, and so 8 divided by 4 is 2, and 12 divided by 4 is 3, so I have 2/3. Now I'm going to cross multiply, and I get 3x is equal to 18, which is 9 times 2. Divide both sides by 3. I end up with x is equal to 6. 18 divided by 3 is 6. So the length of segment AC is going to be 6. Now, if you want to, I would recommend pausing here because I'm actually going to erase this work that I just did for solving for x. You may need to pause, maybe copy this down if you really want to use it to study and have both of the solutions for x and y side by side. So just my recommendation, but now I'm going to go ahead and erase this so I can show you to kind of repeat this process in order to solve for y. Okay, so now we're going to solve for y. So that means I need to create a ratio that involves y, and that ratio is going to be CB over DF, this one right here. CB over DF would be 10, that's the length of CB, over y, okay, and that's going to be equal to the ratio that we know both corresponding sides. Now here's the deal. You could now use this one because we found out that this equals 6. We could say 6 over 9, or we could use 8 over 12. Now, you might have made an error on the last one. Not saying, you definitely made an error, but it's possible. So it might be a good idea to use the ones that were given and then just go back and verify that if you multiply everything by the same scale factor, you get your new figure. So I'm going to be consistent here and use 8 over 12, just in case maybe I did make an error on the last one. So 8 over 12 is the other ratio I'm setting it equal to. Okay, so once again, I can take 8 over 12 and I can reduce it just to make the math a little bit easier. So I have 10 over y is equal to, we already reduced this in the last one, it was 2 over 3. Those were both divisible by 4. And so now I can cross multiply. I end up with y times 2, or 2y, is equal to 10 times 3, which is 30. Divide both sides by 2, and I end up with y equals 15. Okay, so I'm going to write that in here. Okay, now here's the other key piece to this. We can go back and actually check that this is all correct. So right here, actually this ratio right here was our given scale factor. Okay, and we have a scale factor because we're given they're similar, so just to backtrack on that a little bit. So this is our given scale factor, which means if I take the ratio of AB over EF, which is 8/12, which we have found out reduces to 2/3, if I take every single measure and I multiply it by 2/3, I should get all of the corresponding lengths on my original figure. So this scale factor is multiplying by 2/3 to go that way. Now to go the other way, my shape's actually getting larger going from this shape to this shape. I multiply by the reciprocal, which is 3/2. And that's just me taking this ratio and doing the reciprocal instead. So let's just verify this. Let's take each of these lengths and multiply them by 3/2 and make sure that we get the corresponding lengths. Well, 6 times 3 is 18, divided by 2 is 9, so that one checks out. This was given, so we don't need to check that one. 10 times 3 is 30, divided by 2 is 15, so that does in fact work. That's a really good way, once you're done solving these problems, to actually go back and mentally check your work. It's a good test-taking strategy as well. All right, so I hope that helped a little bit with solving for side lengths of similar triangles, and that is it for this video.